Okay, cool. Good afternoon, everyone, and welcome to Production Django. It is my pleasure to introduce Joseph Mosby, who is a Python engineer from the National Journal in Washington, D.C. area. And I'll let you
Appreciate
take
it,
from
Brad. All right. First of all, I need to thank you all for coming because it is literally the last round of talks in here, lightning talks following, and I honestly believed I was sitting down in the lobby and I saw everybody like trailing out and trying to, and I was like, there's gonna be 7 people at this talk, like maybe. And so each and every one of you, I am very appreciative that you're here and excited to talk about Django. So let me first introduce myself. I'm a Python engineer at National Journal in Washington, D.C., as Brad said. National Journal is a political magazine, so we have been around since the 40s covering Washington politics, have a heavy presence. We're one of the few publications that all of Congress has a subscription to, so we're really proud of that. Prior to this, I worked for a PR firm and was a government cybersecurity auditor before that. And I worked with a government agency basically helping cover a lot of the things that I'm going to discuss in this talk, how to keep not only government applications secure, but how to keep them reliable, how to keep them up and available to the general public. So it was something that I was heavily involved in before switching to doing purely web applications in the media. I'm also a classic computing aficionado. I love getting computers from before I was born. I have not built a full Turing machine yet. I haven't gotten the thing with the electronic relays just clacking away, but I'm working on it. And I'm also a Spanish student. So if any Spanish slips into the presentation while I'm going, I'm just practicing. Just roll with it. Y'all just keep going as if I didn't say anything. So let's get started a little bit. And I want to first talk about the agenda and what you can expect to hear in this talk today. We're going to talk for about half an hour or so, leaving some time for questions. And we're going to cover some themes around deployment. We're going to cover some themes around securing the servers. So after you've got code on there, how do you secure them? Make sure that you're able to actually know that your application is functioning without any sort of intrusions. We're going to talk about segmenting the environment, basically keeping different sorts of environment, production, staging, development, best practices for those. We're also going to talk about scaling and preparing for how you scale up your environment. We're also going to go over a few things that I consider gotchas in the sense that they don't neatly fill into one of the categories up above, one of the 4 categories there, but are important enough that I feel like can really snag you up if you're not prepared for them. And then finally, I'll discuss a few tools that we can use to kind of make sure that our monitoring is running, that we're making sure that we're doing all these things well. So this is definitely some things that I wish that I had known when I started writing stuff that was exposed to the general public, some lessons that I learned from others and some that I had to learn by fire. So I really just, these are things that as I was moving, that I'd done a couple Django apps, I'd done them kind of on a personal scale, but then when I started exposing the general public, things that I wish that somebody had told me. So I hope that this is really useful for all of you today. So starting off, the way that I'm going to pattern this out is I'm going to talk about one of the categories about what a lot of us do, stuff that I did, what was extremely common, and then not even going into what's a best practice or what's a wrong practice, just things that I've commonly seen, polling some coworkers, polling some friends who write Django, and some of the patterns that I've seen. And then I'm going to go into what I consider to be best practices. Ways to kind of consolidate all of these general ideas into things that I believe that anybody can achieve in their own organization. So when we talk about deployment, a lot of the ways that most of us start getting things out in production is we do exactly what Heroku says to do. I have the how to get a Python app on the Cedar Stack bookmarked from Heroku. I forget it every time and I have to go back to the guide. But Heroku's got this down. I mean, this is the kind of stuff that they do on a regular basis. They're professional at it. If that works for you, then that's often a very good practice because they've thought about it and they've really perfected that. If you're not using Heroku, then it's common to see Git pulls run with Fabric scripts, things like that. If you haven't worked with Fabric before, it's basically a set of scripts that allows you to automate some step of a deploy or configuration management process. It's nothing more than a sophisticated shell script when it all boils down to it. Some of you have done FTP, which I'm so sorry. I've had to do that before. I've had to deploy Django code over FTP because I had a customer that only gave me FTP rights to a server. And so I was having to basically just drop code on there and then ask them to restart whiskey processes and then just hope for the best. So if you're struggling with that right now, I'm sorry. There is light at the end of the tunnel. And then some of you are also maybe doing continuous deployment. Maybe you've gotten things where you've checked all the boxes off. You're running to where basically you're committing, your tests are running, everything is happening on the server, and you can do this at the press of a button. That works for some organizations. It's kind of the end-all goal, especially when you're talking about the agile software management process. But let's talk about some things about just general best practices that you can get to for deployment in your own organization. And the first thing I say is that whichever way you go for, you need to aim for a single, repeatable, easy-to-execute deployment step, something that anybody on your team can run. Whether it's going to be a Fabric script that you can run, whether it's going to be some sort of pushing to Heroku, it needs to be something that you can document and do easily. Because what I've seen with a lot of development teams is that there often turns into one person being the deployment person, and they're the only one who knows how to do every single thing that's required to deploy to a production server. Getting to something repeatable is huge. Just something that you can say, here's the step you run. This will deploy to production. It reduces error. It makes it easy for anybody in your organization to do it. What we do at the kind of the end thing that gets us onto production at National Journal is we do a get force checkout. We treat our master branch as what production is supposed to be, and we have Fabric scripts that are basically, when all is said and done, executing that command to force master onto the servers. And if there's been any changes, any slight deviations in code, we're blowing them away, and we're saying what we know is on master is what's supposed to be on production. Scheduled versus continuous deployment, you'll see a lot of blog posts and chats about how continuous deployment is the end-all, be-all for deployment processes. That didn't work for us. We found that it was that a lot of scheduled versus continuous discussions are heavily influenced by organizational politics. When we had continuous deployment in a National Journal before I got there, and the problem that we were really running into is that folks within the organization outside of the technical team took that to mean, oh, I can just forget to do my part of testing and then run in 2 days after a deployment push and say, oh, wait, this didn't work. I tested it real quick and we'll push again. That didn't work with our organization. We found that moving to a scheduled process worked for us because it helped us fulfill an organizational contract. It helped us say, look, we're doing pushes on Wednesday. You need to have your tests done by Monday at close of business, and that helped us work with the rest of the organization to really make sure that everybody was on board with deployment. I found that a lot of times continuous has worked if you have an organization that sees technology as being at the forefront, but that's not necessarily the case for every organization. We're a media organization. Our journalists are at the forefront, and getting stories out is what really matters. We follow a scheduled deployment process because it lines up with our publishing process. It's something that's easy for folks to understand. If you need to have your stories in at this point because they've got to go to the printer, it's the same thing that works for us with software. It's something that has helped us keep better code management in with the rest of the organization. Moving on a little bit, talking about security. What most of us do is, and what I have done in the past, is I trust that the hosting provider's got it. I say, you know what, my hosting provider has said, here's their security thing, here's where they get PCI audited, whatever it may be, and what they say to do is just fine. We'll also often see commonly that developers get root access and they get app super user access to everything because the developers are the ones who've got to run in and debug the application. Therefore, they need root access to all of the servers and be able to go in and change anything all the time. But the one thing that we do all do is we make sure that we change our passwords every 90 days because that is the paragon of security in applications. As long as we have alphanumeric and special characters in our passwords, and we change them every 90 days, we're good. We're golden. We have fulfilled our security requirements. But we all know that that's not the case. We all know there's more to do. What has worked for us at National Journal and in the government is first and foremost making a conscious effort to keep sensitive data off of your servers as much as possible. Obviously, there's things like passwords that you can't, but anything that you can get out of the public as quickly as possible to where it's not exposed to the world, do it. We have a lot of information that we manage on back-end applications that the organization needs that occasionally makes it up to the public, but not all the time. And we try to keep that off of our servers as much as possible, because if in the event that we have a front-end server get compromised, we know, okay, we'll have a limited amount of data. We know that we hope that this doesn't happen, but we do know that the data accessible from that server was minimal. And so thinking about how you can clear that data off is one of the easiest, the low-hanging fruit to actually make sure that if you have a security problem, they can only do so much damage. We also take the tack of restricting everyone's access, and especially developers. And the reason we do this is because we know just enough to get ourselves into trouble. I know just enough Unix to break things. And to get in there and say, oh yeah, I know how to run these scripts. If you give me sudo access, I will start changing permissions without thinking twice about this. I know it's bad. I know that it's a bad practice. But I also know that if I have somebody standing over my shoulder wanting me to fix the problem in 15 minutes, I'm going to change the permission if that makes me actually get the code working as quickly as possible. We also have a tendency to make mistakes. Is that I don't necessarily know everything that could possibly go wrong if I'm doing something. Taking, for example, there's recent poll that came out where 1 in every 600 public-facing web applications has their .git directory exposed to the world, which has everything in it. It has every change that you've possibly made, every time that you've accidentally committed maybe your API keys or things like that to the world. It's out there. And it's the sort of thing that I don't necessarily think to check for myself. My system administrator is thinking about that sort of stuff. My security officers are thinking about that, but I'm not necessarily thinking about that. We just know that the larger the attack surface, the more people that have privileged access, the higher the risk that you have. And the more that you can actually avoid those problems, the better off you'll be. And planning for these sorts of things is huge. Planning for the problems, thinking about this, working with non-developers to think about this is extremely important for you, because we find that when we work with non-developers to make our contingency plans, two things happen. First, we think about a lot of functional problems that constitute some sort of security, constitute application problems that I'm not necessarily going to think of because they're organizational problems, not necessarily problems in the code. Take, for example, for us, something that's not quite a security thing but has to be worked with security is we had on our last CMS, we had a journalist that accidentally deleted 600 stories. They were basically running an open query, trying to find a story that they had, and then deleted all those stories because they had the right to do it. That's a simple fix. We don't let people that aren't editors delete stories. We basically say we're going to take it wasn't some sort of compromise thing. It was an honest mistake, but it's something that can be fixed with security. So thinking about bringing developers and thinking about that helped us catch that problem. But the second thing that it does is it helps us really cover a lot of the things that we'll make excuses for ourselves. We will often say, okay, yeah, like I know that I tested this on my machine, I tested this on staging, it worked. And then you'll bring a non-developer in and they'll throw some data you didn't expect at it, and suddenly your entire application crashes. Those sorts of things, working with your functional teams, people who aren't necessarily engineers, is huge because it helps you catch all of those and keeps you honest. It keeps you from actually saying, okay, we've got this down, I tested it, I did what I expected to do, my unit tests have passed. But if a non-developer comes in and is able to break the application with one bad entry, then you know you've got a problem that you can't explain otherwise. And the last one was a tip that I had a fellow engineer of mine brought this up to me as I was planning for this talk. He said it was often common for him to be running a lot of smaller applications that were all exposed to the general public, But because they were lower traffic, he was able to run a lot of applications off the same server. And he had a situation where his server got compromised and was able to destroy all of his apps at once. If he had had different users each executing those individual apps, then it wouldn't have been a problem. One user gets compromised and it can only do so much damage because it only has so many privileges. So think about those ways to segment that out. That leads us a little bit into segmentation as a whole. What is very common to see, and was very common when I started writing Django apps, is I would set up something on my local machine, which is a Mac. I would get Mongo or Postgres running on my Mac, and then I would suddenly run into all sorts of issues when I started pushing to production, which was Linux, and was running Linux drivers. I was running virtual environments, I was doing all of that stuff, but the fact of the matter is that things were a little different from my local machine to production. Segmenting that out, I thought that if I just kept things on development, I was able to show folks on a smaller basis, then once I pushed to production, it was going to be fine. But I'm still running into problems where a script isn't necessarily connecting in the same way on an environment. It's misusing an environment variable, and doing that, I was not catching it until I actually pushed to prod and hoped for the best. So my recommendations here, this was something that gets hammered home in government. We've taken it to use it at National Journal as well. You keep a dev environment that is a copy of prod. We're using Vagrant for this. So we're going to be getting once, we've finalized a few things, we're making some changes, but basically we're going to have dev run as a Vagrant box with running the same Ansible playbooks that our production runs. I'd love to say we're doing it now. We're working on it. But dev is basically calling in the same Ansible playbooks that we use for our production scripts. And Vagrant plays very nicely with this. You can basically point these same configuration management scripts. You can have Vagrant running off of Puppet and managing configuration in that way. And it runs the same way. Same thing with staging, where we make sure to keep staging in line with production, but keeping production data to be a part of our staging environment. And going back into our segmentation of different environments, talking about sensitive data, keeping data segmented in production as best as you possibly can will be extremely helpful. For us, we have our CMS, which keeps a lot of draft stories, a lot of draft content, a lot of things that we really don't need the general public to know. Especially if it's something where we're using it for back research or things like that. We keep that on a totally different set of servers than we do for production that the general public sees on our news site. It's obviously still production. It's used by production folks, but what's used internally by our journalists on the CMS side, we consider that to be totally different than what the public sees. Considering that as a sub-segmentation, it moves you a little bit closer to a service-oriented architecture mindset. We're able to actually pop off components as you have need, but still have all of these applications working in tandem together. And then finally, my last four categories, scaling. What most of us do, again, is we do what Heroku says, which is good. Heroku is built for scaling. It's built to handle all of this. Or if you're using Amazon Web Services, you're able to pivot a little bit off of that. If you're running Microsoft, Azure does this. But doing what Heroku says is fine. The counterpoint, though, of what I've seen is if you are not doing what Heroku says, it's often common to handle it when it becomes a problem. We put something out there. We hope for the best. And then we handle it when it becomes a problem. It is much, much harder to handle it when it becomes a problem and you're panicked and trying to get the servers back up than if you'd handled it ahead of time. Handling it ahead of time is super simple. It requires 3 servers, it requires a load balancer, and it requires 2 app servers. This is a very, very basic configuration that primes you for scaling, for large scale as you have need. You can pop off the app server. You can say, you know what, I'm gonna test and say what happens if my app server goes down. The load balancer is able to handle it, route all your traffic to app server 1. App server 1 just straight up crashes later on. You're able to say, okay, well, I'm able to just tack on app servers 3 and 4 and be ready to go. If you have this configuration set up from the beginning, it is much easier to hot swap servers as you have need, to spin up new instances as you have need, but it is much harder to set up this configuration after you've already started running into problems, because the panic set in, your application is not necessarily built to handle it, and you're running into all sorts of problems down the road with scaling that you weren't prepared for. So one of those that really becomes apparent with scaling, one of these gotchas that I want to talk about now, is storing images locally. So storing images locally, it's often common. Okay, well, my users are going to upload files to their server. They're going to say, I'm uploading my profile picture or something like that. If you have not built with scaling in mind and your servers start to go down, that user data gets completely lost. If you're uploading into a local file system, that user data gets totally lost, but your Django database is going to be set up because it's actually prepped for it's stored file objects that are pointed at exactly those places on your server that's now dead, and your files are corrupted. Your entire data structure is corrupted here because it's expecting a lot of information that's no longer there. The way that we handle this is we have shared across those two app servers. We have a networked file system that is basically keeping those in sync with each other at any given time. So when a user is uploading something to the media files folder, they're actually uploading into a networked file system that we've set up. It's able to keep those things set up to where they're not dependent on one server, and we're able to, again, synchronize this with every single server that we have that we spin up later. The Django admin console is another one of those things that we use a lot. It's a Django application. We commonly use the admin, but we've also run into some problems with scaling because the Django admin console obscures so much information away from you. It's now, I remember back when I started messing around with Django before it was even 1.0, the admin console was there, but it didn't do a whole lot. Now it does so much, especially around managing things that are foreign keyed together. All of these relationships, they're totally obscured away from you. But if it starts to run wild, if it starts to have a bunch of out-of-control queries and things like that, it's often that you didn't actually build the things that the Django admin console just lets you do. So we've run into a couple problems with scaling around that, most notably that it allows us to simply run out-of-control queries. And I think that this is best demonstrated by an example and how we can probably solve this. So an out-of-control query looks a lot like a great query. You can see here that let's say that I'm calling to our congressional members database. We have a huge database that tracks all of this information about members of Congress and their staffers. So let's say that I'm filtering for people that have been on the Ways and Means Committee ever. I want to say people who served in the House of Representatives Ways and Means Committee, which is hundreds of names. And I want to say for each one of them, I'm going to pull out their chief of staff because I'm just looking for a list of chiefs of staff who've worked with this. Each time that you go through the loop on this first thing, you're making a new connection and a new query to the database. So you're basically saying every time I'm doing a select one, and you're peppering the database for each time you go through the loop. But to change that, to make that look a little bit nicer, the select related statement actually will pull all this ahead of time in one query. It's actually able to just pull those models out in one query and have them accessible for you, keeping the data from that one query in memory so you can access it later in your application code. It's a small change. You added one line of code into this statement, but if you're starting to have issues with your queries basically running wild and hitting your database in ways that you're not expecting, this could be something to look out for. Are your queries starting to run away with you because the application code doesn't really tell you how it's executing that? And so let's talk a little bit about tools that we can use to address some of these things that I've been discussing. Django Debug Toolbar does a great job at actually catching this very thing that I've just discussed. The Django Debug Toolbar is there to basically track a lot of information that you'd normally need to see by having a Django error pop up. When Django spits out all that information in debug mode, the Django Debug Toolbar actually shows you all of this information in a friendly little JavaScript sidebar on all of your pages. So here, it's tracing through all of the SQL queries that it's making to your database, and it's showing you the time that they're taking. We use this to actually see that very query that I described, where we were looking for the staff members and members of Congress. The way that we originally built this, when we were setting this database up, is we'd had somebody who was not terribly familiar with Django that had originally gotten in there and had set up a page that was running 12,000 database queries with each page load. It was creeping a little bit. And so we got in there and tried to figure out what was going on, and we suddenly said, we looked at this, and it's like every single time, 12,000 queries to the database just for loading the page. You refresh it, does it all over again. And it was because we weren't selecting a lot of those related objects in the same query. We knew we had a complex page. We knew we had to bring in a lot of this information, but the way that we were doing it was putting a huge strain on our database. So I'll also tell you things like CPU time, data about the request, the templates that you're calling. It will show you actually trickle down through the hierarchy of templates that you're bringing in. So it will show you if you have missed an include statement or something like that. The Django debug toolbar is a huge friend here for showing you a lot of this information, helping you go through it. New Relic is another tool. Even the free tool, highly recommend that you get this on your applications. This is our PHP application that we are running as well. It had more data to show, so I called this one, but the Python stuff looks exactly the same. Shows your response time, shows throughput on the application, shows their AppDex score, which is a complex score of the health of your overall application. It will also show a lot of stuff about your database response time and just track through how your application is performing. The free tier has so much information available to you. I believe that the one thing that it offers, that the paid version offers, is it offers a lot of complex alerting if you start to have problems. But a lot of the information is still there just in case you need it right there. Sentry is another one that we use that shows a lot of information about the errors that are spawned by your Python application. Even if you're catching them, it's still there. But errors that pop up as you're running your Django application, it will catch them all and show where those problems are arising so you can debug them later and which ones are commonly being seen in your application. Supervisor, one of the things that I actually found when I was trying to build this slide is that it is super hard to find screenshots of Unix applications, like scripts, command line stuff. There's a lot of great documentation about Supervisor, and there's not a single screenshot of what Supervisor looks like on the Supervisor Read the Docs page. It was astounding to me. I'm like, at some point, somebody should have taken a screenshot of this from their terminal, but no, it doesn't exist. So I have this instead. Supervisor is a process monitor, and it's a process monitor that basically you can attach your celery process to, your whiskey processes to, and it will basically monitor and set up sub-processes to make sure that those are still up and running, that whiskey hasn't crashed on you, that celery hasn't crashed on you, and you can configure alerting to actually set those things up if you have problems. So we use this for the whole. It basically, we do most of our work just making sure that it's still running, but it will actually track through if you've intentionally stopped a process, if a process has totally failed or exited unexpectedly. So it's very simple, has a very simple job, but has been extremely useful for us as to just making sure that the application is still up and running. And Flower is the last one I want to talk about. Flower does monitoring of your celery queues. Flower is there to basically track what comes into a celery queue, regardless of the backend that you're using, and will keep that information, what functions it was trying to call, what tasks it was trying to run, what inputs were coming into that task, and success or failure rates on those things for each worker. So if you're having issues with celery tasks not completing as you were expecting, Flower's there to help you debug that information and to make sure that the health of your application is still humming right along. So that's it. This is kind of the end of my talk. I've included the slides there. If you'd like to use these later, feel free to fork them. Feel free to bring them in for future talks. If you'd like to get in touch with me, I've got some contact information up there. But I intentionally left time for questions, so please feel free to chat. Oh, and they got to get the microphone on you so it's captured on video.
Do you have any advice as far as maintaining the different versions of like settings.py between the different environments?
Yes, that is what we have. What we have done is something that we're changing. So I'll say what we did in the past, and I'll say what we're changing to. We have right now one of the things in our Fabric scripts for deployment is it actually removes that settings.py file and stores it temp elsewhere. So basically, it keeps a backup of the settings.py. So when we push onto our different environments and we override all of that code and version control, we actually are keeping different versions of settings.py and we'll put them back in after the fact. So it's basically the workflow is copy the settings.py file out, run the force checkout, push all that code in, and then put the environment-specific settings.py file back on the server. That is painful, and it especially means that you have to, anytime that you want to make a change to settings.py, you have to go onto each server and do that individually. What we're moving to is we're moving to keeping that all in environment variables and using os.environ to basically pull out those environment variables from each one. And then, so that allows us to keep settings.py where it's basically saying, give me the OS environment variable named databases. And then we're able to say, okay, the databases is stored in each server where we know that each server has their own local environment variables that we're able to manage through Puppet, and Puppet's doing the configuration management there. And then the settings.py file basically just imports that environment variable from the server. So os.environ is the command that will allow you to extract those back out, and then you can treat the settings.py logic like you would expect.
So I think I missed the answer to my question when he was handing me the mic. Where do you store the environment variable settings?
We're keeping those in Puppet. So Puppet's doing configuration management on each server. So the server has a Unix environment variable set, and then os.environ is able to actually extract those from the Unix environment. So each server has their own settings.
Where does it store it on the server? I mean, it has to be like a script or something that runs through and sets all those.
Yeah, so Puppet is able to go through and set environment configuration variables. Basically, like when you're able to change things in like your bash profile. It's that same sort of thing if you're setting a Unix.
That's what I was looking for, is the specifics of, is it bash profile that it gets stored? I've always kind of wondered, I've heard people say use environment variables.
Right.
I've always wondered how is that, it's a text file somewhere on the server.
Yes.
And how is that different from a settings.py file, which is also a text file on the server?
It is no different than settings.py, which is a text file on the server. So settings.py is something that you would naturally keep in your version control, correct? But your text file on your Linux server with all your configuration variables for Nginx or for Postgres or whatever it may be, we basically keep those in there's a text file somewhere in Unix world that I would love to give you an exact path to, but I don't know it's there. But you're able to say, in this server environment, we're keeping these variables that are specific to the server. And it's stuff like one of the variables that Unix keeps is what you want your prompt to look like. Same thing is that you can keep a text variable on a Unix server that you run. The command I believe is export, and then the variable name equals so and so.
I guess the difference to what you're saying is these things are managed by Puppet,
Right.
where settings.py stuff is managed by Git.
Yeah, it's managed by Git, and
that's why it's better to do it this way than that
correct.
way.
And each Puppet can basically say on these servers we're going to connect to the staging database. On these servers we're going to connect to the production database, and it's able to keep different database variables on each server.
And Puppet's better managing environment variables than setting.py.
Yes.
Okay, that's starting to
Yes,
make
Puppet
sense.
is considerably better because it's built at actually keeping those it's doing that configuration management specifically on a server level.
Yeah, okay. Can I ask another question now? So secrets like passwords. If you've got your login credentials for the database and maybe some API keys and that kind of thing, how do you store those?
We also have them as environment variables. And so when settings.py, we say API key equals, and then we call in the environment variable, saying that we know that those are exposed out of version control.
All right, any other questions?
Hi, I think I heard you mention that your company stores user-uploaded media on a NFS server, right? I was just wondering if there was any particular reason why you guys do that instead of using like an object storage service.
Like S3 or something like that.
Yeah.
We do that. I believe that it's one of those like corporate policy things that we have to do. We don't generally have enough media where it causes too much of a problem for us. Most of the media that we have is, when we say user uploaded, it's somebody within the organization. We could use Amazon S3 for it, but it's something where we have gotten really good at keeping that internal, and we've got the servers, we've got the space, and long before I got there, we were doing it that way.
Could you describe this Django debug toolbar? Is it something built into Django? Is it a third-party add-on?
It's a third-party add-on that you can download through pip, and when you get it on pip, it's Django debug toolbar, and you install it through pip, and it puts all the necessary JavaScript and things like that into your Django app.
But you also have to install. You have to put it in your install apps.
Yes, correct.
Any other questions? Okay, I have one.
Okay.
Actually, two.
Well, you've got the mic, man. You're ready to go.
Right. I might come up with more. So
There you go.
Python 2 or Python 3?
We're Python 3.
Excellent. So question number 2.
Okay.
How are you using Fabric? Because it doesn't work with Python 3. Do you have a second repo for like deployment stuff with Fabric, or what are you guys doing?
It's more that we are doing. The Fabric stuff is being written to some degree with Python 2 stuff, and that is being done by I believe our sysadmins are still using Python 2. So I cannot say we're a purely Python 3 organization. All of our application code is. The stuff that I'm responsible for is. And therefore, I get to say, yeah, we're totally Python 3. But yeah, our sysadmins are still doing some stuff with Python 2. I believe they have a couple maintenance tools as well. CheckMK, I believe, is one they're using to do a lot of like stuff, synchronization with Nagios for server health. And that's still Python 2 as well.
Do you know if they're looking at Invoke, which I haven't used it, but I think it's the successor to Fabric?
I do not know. Maybe.
Yeah, cool. Python 3 is awesome.
We love it, and the best part about it is that we had to convert some PHP developers to Python, and it's really great when you just don't tell them Python 2 exists. So you just start clean from the beginning. You're like, yeah, we don't know what Python 2 is. Print has always had parentheses involved.
I have two questions. I heard you mention Ansible, so I was wondering if you're moving from Fabric to Ansible or if you're still using both, and how did they work together? And then the next one is, do you use environment variables in your supervisor file? Because I found out that you can.
I can tell you what we're using Fabric and Ansible for now. I don't know if we're planning to merge them. Right now, we're doing Ansible strictly for new server spin-ups. So we're basically before we actually are managing a lot of these deployment things, just getting a new server up is being all done through Ansible playbooks. I do not know if we're planning to integrate a lot of that work. Right now, Fabric is strictly doing deployment stuff, and that's it. So the Fabric scripts are extremely simple. I don't know how we're planning to integrate those in the future.
Can I jump in?
Go for it.
So I'm using Fabric and Ansible. Ansible does deploys and configuration. But I can't ever remember the commands to Ansible, so I wrote fab commands. So fab prod deploy kicks off my Ansible
Yeah, there you
stuff.
go.
But Fabric for like ad hoc stuff. So if I need like a management command that I need to run that does some reporting, or I need to do any sort of intervention, that's a
In addition to Django debug toolbar, I like using Django extensions. So, and then in my settings file, I have if debug, and then I have those. And Django extensions gives you shell plus, which is really nice.
We are using Shell Plus as well. I did not bring that one up. Django extensions has something called Shell Plus, which honestly I don't know everything that it does, but it does one great thing, which is import all of your Django models at once. I'm sure that it does a whole lot more, but that was enough to get me to start using it. Because basically you run Shell Plus and all of your models are just there ready for you, and you don't have to remember where all of them are stored in which apps.
yeah. I third Django debug toolbar and Django extensions. They're absolutely necessary. So any other questions? Anyone else?
Thank you all for
All
coming
right.
out.
Thank you.